Hello. In this video, I'm going to talk about Terraform modules, and we're going to look at a new AWS service called ECR, or Elastic Container Registry, which is a bit like S3 for Docker images, or a private Docker hub, for example. Let's start off by creating an ECR repository. I'm going to put this in a subdirectory today, just because I want to demonstrate some module things later. So let's go ahead and set up our backend as usual. I'm going to use this bucket for put it under a prefix there, and then I'll go EUS2. So that's the basic setup, and then for the repository I need to do ECR repository service A. And the only thing that I need here at this point is to set a name. So let's call it, let's do team A service A. Now if I go in here, change into my team A directory, we can see we've got main.tf. I will do init. And then I'll apply that straight away. And you'll see that we've got this ECR repository being created with the name teama/service A. And I'll show you what that means in a second. The other values, the known after apply, we will find out. Image tag mutability is to do with whether you can sort of move tags from one image to the other. So for development images, that's probably fine. If you're running images in production and you want to be really confident that you've got the right image for a given, commit char, then you would probably set this to immutable. But let's create that. Now, if I go to my console, this service in AWS is called Elastic Container Registry. And this is a classic thing. It set me to, you can't see. It set me to United States up here, so I just need to click on this drop down and go to London. There you go. Now I've got this Team A Service A image, repository. If I click on it, there's no images here, but if I go to these push commands, then I can see how to log in and then how to tag and push an image. So let's go through those. I will put this over here, and then let's log in. So I've got the AWS command line installed, and I've also got Docker installed so that Docker login works. And it gives me this warning about logging in with a password, but that comes from Docker itself. And actually the login password that the AWS command gives you is time limited anyway, and this will expire. So it's reasonably secure. Now I'm just going to pull a random image. This is Alpine, which is a very small image, so it didn't take too long to download. Imagine that this is my service. Maybe I've got some kind of microservice or web server or something that is built into an image. I can tag it with this is my registry, and then this is the repository, so team A service A, and then the colon tag and latest. There's actually nothing that special about the tag latest. The only thing that treats it specially is the Docker command line. If you do a Docker pull and don't specify the tag, it will look for the latest one, but otherwise it's the same as any other tag. Now I'll push it. We can see it's been pushed, and it gives me a char digest. If I refresh this page, I've got a latest tag, and it's about 4 megabytes, and you can see when it was pushed. So there's the repository, and we could go away and use that image in as a dev container. We could use it in an ECS service, any of those things. But let's turn that into a Terraform module now. Actually, the first thing we'll do is set a lifecycle policy. So you can imagine if you had a CI system that was pushing an image on every merge to your main branch, for example, these images would build up over time, and you would have lots of them. I think the default limit for images in a repo is 1,000. So eventually you'd get an error where you couldn't push any more images because there were too many in the repository. So what we can do to avoid that problem is set a lifecycle policy. And you can see it's in the console here as a lifecycle policy, but let's do it from Terraform. So we'll do AWS ECR lifecycle policy, and then we need to set a repository, which is this one. And again, I'm referring to it by the attribute so that it's got a dependency link. And then I need a policy. And I could, in the Terraform docs, refer you to using this JSON encode function and then typing it out in here. But let's be a bit more sophisticated and use a policy document data source, because this will give me, I can type, it will give me some, let's say keep last 10 images, and then we want to set, so selection, and we can do tag status here. So you can set rules that work on tagged images, untagged images, or any image. So in this case, I'm going to do any, just to cover all of them. And then let's say count type. And this isn't, I'm cribbing this from the docs, but it gives you some help here. So count number 10. So what this will do when we apply it, so go up here, and then I do data. And this is, so data, AWS ECR lifecycle policy document dot policy, and then I need to put JSON on the end, because this data source exports a string of JSON basically, and then this argument is expecting a JSON blob. So if I go and apply this, then what that will cause AWS to do is roughly every 24 hours, it will run this rule over all the images and say it will order them by when they were pushed, and then any that are more than 10, so image 11 to however many you've got, will be expired. And if I go in here, you can see there's this keep last 10 images rule. Expire if the image count is more than 10. And you get a log of when things are deleted as well, which can be handy. The storage here, so you saw when I pushed, there was this here is a layer. So more complex and bigger images will be split into layers. And what ECR and most Docker registries do is they deduplicate the layers. So layers with the same hash probably have the same contents, so you only need to store one copy of them. And what that means is that if you've got an image which is based on a base image and you're just putting, say, different code into it, then the base image would only be stored once in this repository, and the other layers would be stored individually and then combined with the base layer when you pulled it. All this to say that the storage used by this repository, which is backed by S3, but billed as ECR in the billing console, the storage here is not the sum of this column when you've got more images. It will be less than that because of the layer deduplication that Docker registries do. Okay, so we've got an image and we've got a repository and a lifecycle policy. And that's not too many lines of Terraform. But what we might want to do is create multiple repositories. So we can do that just all in this file by doing locals, and then I'm going to do repos, and then I'll cast it to a set here. Sets are a bit weird in Terraform. It's basically a list that is ordered and deduplicated, but you don't need to worry too much about that now. Just know that if you're doing for each, you can't pass in a bare list. You have to convert it into a set at some point. So let's do service A and service B. Now I'm going to do repo, and the name, what I'll do is do for each local.repos, And then in name, I want to put tmay and then slash dollar curly brackets each dot key. And now to iterate over the lifecycle policies, I want to do for each equals AWS ECR repository.repo, and then the repository should be each.value.name. And the policy can stay the same because in this case we're using the same policy. So this value doesn't need to change based on which repo we're working on. In this case, I'm going to sort of add that on later with some variables. But for the time being, we'll create 2 repos with the same policy. Let's do an apply. It's going to try to destroy this, which it won't be able to because there's an image in it. And I'll go over that later. But for now, what I will do is move it. So let's say no here. And I'll do Terraform state move from this to this. And I need to put single quotes around that because of the shell I'm using. There we go. Now if I do an apply again, it should show. So it's going to destroy this policy and create a new one here, which is fine because the policy can be destroyed and recreated. And it's already aware of the policy and the repo for service A, so it's not making any changes there. There you go, and we could extend this list and make as many repos as we liked without having to write lots and lots of Terraform, which is quite nice. Now what we might want to do is have multiple teams with ECR repositories. So let's start by creating a module. And a module is just another set of Terraform files that we then call from a Terraform stack. So we'll do modules. Let's do ECR repo. And then in here, I'm just going to start with a main.tf and variables.tf. Because what we're going to do in this module, we're going to create the name and the lifecycle policy. So we'll do variable name and then description. Let's do type first. So type is string, description, name of the ECR repository. And I won't set a default value because if I set a default value, then this will be an optional variable. But obviously you need to know the name to create the repository. So I'll take that away and make sure that we get past a name from whoever's using this module. And then in here, I'll do ECR repository, repo, name is var.name. Simple enough. Let's create the policy as well. Actually, I'm going to copy and paste that. I'm just going to rename. So I've got policy here. This doesn't want to be a for each. This can go. Repository is repo.name. Policy is there, and we'll leave the policy like that for now. And now what I can do is I've got this module which has got everything that we need. It's got the repo, the policy, and the policy document. Let's go and use it. I'm just going to tidy up this one that we created in here rather than moving things around. So I'm going to set force delete true to allow Terraform to delete the repository. You can see it's setting force delete equals true, which means that when I remove these, so then I'll set up my module in here, and what we do is we say module and then an internal name, and then we do for each over something in this case, and then source, and the source, if I type this, I can do .. and you can see VS Code and the language server are suggesting this local module, which is great. And then I'll do name equals each.key. And then anytime you change a module source, effectively you need to do Terraform init. Now what I'm going to do is remove this stuff. And if I apply, you'll see that it's going to remove the ones that we created here and then create them inside the module. And that's gone through and done that. So now if we go and look at ECR, I look at my repositories, I've got service A and service B, and you can see that I'm missing the namespace. So what I'll do here is just go in and do team A / and then dollar bracket, finish the quotes. And this is going to delete and recreate them again, but that's fine. And the reason we would namespace them is if, I mean, obviously your services that you're actually working with probably have more descriptive names, but team A and team B could have a service called application or database or something, or an image called application, and you wouldn't want them to clash, collide with the name. So we can do team A / application, team B / application. Now let's take a look at using that module elsewhere, just to demonstrate that. So I can do a new folder, team B, new file, main.tf. I'm going to be a bit lazy. Copy all this. Make sure I rename this. Service A, service B. And then I've got the same thing here, and let's just change this to team B. And now if I change into the team B directory here, and I do an init, you'll see that it's downloaded my ECR repos module from there. Downloading the AWS provider again. If we do an apply here, it's going to create service A and service B. Now if we change back to our console, you can see we've got team A, service A, and then team B, service A. So you can see it's very easy to make lots of modules now just by using this module in each of the sort of stacks that we've got. And the modules in this case are local to the repository, but the best way to do this really is to keep them in probably a separate Git repository. And then when you do an init, Terraform will go and fetch it using your local Git credentials, or in CI it can fetch it using the Git credentials there, and it will go away and get the module, and you can version them then, so that if there are changes to the modules, could be the resources, could be the variables, any changes can then be rolled out progressively through different tiers, different applications. Let's just do another bit of work with variables and outputs. So what I might want to do in this case is have a repo where one repo keeps 10 images and another repo keeps 100, for example. So if we go in here, we can create a new variable, max image count, and this type will be number. Give it a description, and let's set it to default so that we don't have to set it. And now, in the module source, we need to use this variable. So this will be max image count, and this will be max image count. And then if I want to set that, there's a few ways I could do it from somewhere that calls the module. So at the moment, there won't be any changes here because the default is 10 and it was set to 10 before. But if I, just to demonstrate, if I change this to 12, then when I apply, you can see it's replacing my policies because it's changing it from 10 to 12. But the easiest way, if we wanted to configure it per repo in a given thing, so we could just go through the full loop here. We could go in and do max image count is 10 here. And then the apply is no changes again because we've overridden that default to 10. But let's say that service A, we wanted to keep 10 of them, and service B, we wanted to keep 100. We could turn this into a map and then do service A, and then max image count is 10, and then service B, max image count equals 100. And we've changed the type of that local. So it was a set, it's now a map. So each dot key should still work here, but max image count, we can do each dot value dot max image count. And if I plan this, you can see that the policy for service B, which is the one that I set to 100, is using that value of 100. There's one last bit I want to talk about on these map variables, which is what if we wanted a default. So if we wanted, say, service C, and we didn't want to have to set something, and we wanted to just use the default, if we just do this, then the plan will fail because it doesn't have a max image count. So what we can do to get around that, in this case, is use the try function. And what the try function does is it goes through in order these values, and it uses the first one that doesn't return an error, essentially. So if I set that to 10 and then plan, it wants to change service B because I still haven't applied that, and then service C will have 10, even though we haven't changed this, set this value here. And if I then wanted to, I could remove this. And we can see it wants to set 10 and then set 100, just as before, but with sensible default values. So let's go ahead and apply that. Okay, there's another, so that was variables and setting default values, and the try function, which is quite handy, and you can look that up and see more examples of using that. The last thing I wanted to cover in this sort of introduction to modules is outputs, which are quite useful. So if we go into our modules directory, we can create a new output in this module, and let's call it repository URL, and then we'll do value equals AWS ECR repository dot repository URL. And then if I go in here, and I could put this, again, Terraform combines all of the files that end in .tf into one and looks at all of them at the same time. So it doesn't matter if we put this output. I could put this output in a new file in outputs.tf. Let's do that. Actually, I'll do it in the same file just because it'll be easier to understand. So let's delete this. Because what I want to do here is output repo URLs. And then because the value that we want to output here is a list of the repository URLs of the repos that we've created with this module call, what we can do is a for. So not for each, we'll do for. So we do square brackets to give us a list, and then we do for, and we'll do repo in module.repos, and then repo.repository URL. And you might be wondering, I can see where module.repos comes from because that's the path here, and I can see where repository URL comes from because that is the output in the module. So we've got output repository URL. What's this repo and repo? And the answer is that can be anything. It's set in the in value here and then used after the colon. So let's do thing. Now if I do an apply, there are no changes, but the repo URLs have been added to the output. And then that's useful if I wanted to, if I had an image I wanted to push to service B, it's very easy then to go, this is the output. Let's docker tag this with latest, and then push. Makes it very easy to find the URLs. And you can output outputs from the top level, in which case they end up here, or if you were using a different module, maybe you were setting these as a parameter that that something was looking up, you would set you could set them in there. So you'd do value is, and you could do the same thing. So you can pass those outputs around essentially from one module to another module, or output them at the top level. I will do one more thing on variables, which is that at the moment, if I try to destroy this, and let's do that. Because I just pushed an image to service B, I think it was, the others will be destroyed. Service B will say, can't delete this, still contains images, consider using force delete. So what I will do is go into my variables of the module first and do variable force delete, and I'll do type is bool, true or false, description, whether to forcibly delete the repo even if there are images in it. Default, and what we want to do is default to false here, just for safety probably, because if you're using this module in lots of places, in most cases you probably want to stop it forcibly deleting things, because you don't want to lose those images. So we'll go back into team B, and then in this module here, you can see I've already got force delete, and I'll set this to true. And then what I've forgotten to do is go into the repository and set force delete based on this value. So force delete now will be the value of force delete, which will default to false unless we override it in the call to the module. And I almost certainly need to do an apply here first. And actually, in this case, it's going to create all the repositories again because I destroyed them. So what we could do, we don't need to, we could just create them, destroy them again. But for example, if I comment these out, now if I do an apply, all it's going to do is create the policy, the lifecycle policy, which got destroyed before, and then it's going to set, this is the important thing, it sets force delete to true on the repository. If I say yes, now I should be able to do a clean destroy. Yes. There we go. One part of ECR that I haven't covered is the repository permission policies. It's quite a complex topic. I mean, you could spend hours and hours learning about it. But if we go into one of our repositories and then go into permissions, you can see there's these permissions here. And this is an example of a resource-based policy in AWS. So IAM has two types of policy. There's a resource-based policy and an identity-based policy. And an identity-based policy is the policy on my user or role when I'm running. So I have administrator access on the user that I'm using to do my Terraform at the moment, which means that I can do pretty much anything. It means that I don't need a repository policy to be able to make changes to that repository. What you can do, though, because you can set both, you can allow or deny in the repository policy, and then that will override other settings. So the docs here have it, so if a user or role is allowed to perform an action through a repository policy, but is denied permission through an IAM policy or vice versa, then the action will be denied. So you have multiple ways of allowing and denying access. A user or role only needs to be allowed permission through either a repository policy or an IAM policy. So this is why, even with no permissions on the repository, I can still operate against it. It's because I have it in my identity-based policy, basically. This document is actually quite good. If you do need to look up IAM policies and things, I'll post a link to this in the description. Take a look, because it would take hours to go through it now, and this video is already quite long. Okay, so we've gone over quite a lot. We've done Elastic Container Registry, we've tagged some images and pushed, we've logged in. We've also created our first module, which is this ECR repo one, which has some settings. You can set how many images to keep, you can set the name, and you can set whether to force delete. And then I've gone over how to call it from either a list, as we're doing here, so this will use the default values, or if you wanted to set different values here, and you could set force delete differently here, for example, and then you would do force delete, and we would do the same thing. Let's just type that in for my completeness. Each.value.force delete, or default to false, perhaps. And we've gone over outputs as well, so you can output things from inside the repository, and then we would either pass those into another module, which we might look at another time, or we'll just output them into the terminal or into the Terraform output to use for other things, doing a Docker push with them. Okay, I hope that was useful. I hope that was interesting. As always, if you've got any thoughts, if you've got any feedback, if there's anything you'd particularly like to see, leave a comment. Otherwise, thank you for watching.